Imagine a time when our planet, after a warming period, suddenly plunged back into icy conditions. That's the younger Dryas for you. This was not just a regular winter's chill. No, this was a period of a swift and dramatic climate shift that took place approximately 12,900 to 11,700 years ago. It was like Mother Nature abruptly changed her mind and decided to plunge the planet back into a deep freeze, right after a period of warming. It's a bit like stepping out of a cozy, warm room into a cold, biting blizzard. The younger Dryas, named after a tundra wildflower, Dryas octopetala, is one of the most intriguing climatic events of the recent geological past. It was a time when the Earth's climate system was in a state of rapid flux. The planet had been warming up from the last ice age, with glaciers melting and sea levels rising. But then, in the blink of a geological eye, conditions swung back to near-glacial extremes. Now, imagine the impact this sudden shift would have had on the Earth's ecosystems. Forests that had begun to spread were suddenly halted in their tracks, replaced by the barren, icy landscapes of a glacial tundra. Animal species that had started to adapt to the warmer conditions were thrown into a fight for survival against the cold. This sudden cold snap had a profound effect on the Earth's biodiversity. It was a time of great disruption but also of rapid adaptation and evolution. Species that could not adapt quickly enough to the new conditions faced extinction. Meanwhile, those that could survive the cold thrived and expanded. And what about the humans? Well, they had to adapt too. The sudden cold would have forced our ancestors to develop new strategies for survival, from finding new food sources to inventing new tools and technologies. This abrupt return to glacial conditions marked a significant moment in our planet's recent history, setting the stage for one maverick geologist's extraordinary theories. Enter Randall Carlson, a geologist whose unconventional ideas would challenge our understanding of the younger Dryas. This maverick geologist has made a name for himself not just in the world of geology, but also in the realms of astronomy and anthropology, thanks to his interdisciplinary approach to scientific inquiry. Randall Carlson is a man who looks at the world through multiple lenses, and this perspective has led him to develop extraordinary theories related to the younger Dryas. One such theory is his flood hypothesis, which posits a colossal flood during this period, a flood so vast and powerful that it left indelible marks on our planet. So what evidence does Carlson present for this flood hypothesis? For starters, there are the gigantic ripple marks. These geological features, which can be seen in various parts of the world, hint at a powerful force that once swept across the land. Then, there are the meltwater channels, which suggest a sudden and significant rush of water, a phenomenon that aligns well with Carlson's flood theory. And let's not forget the erratic boulders, those massive rocks which seem out of place in the landscapes they inhabit. According to Carlson, these boulders were likely carried by the immense floodwaters and deposited in their current locations. These geological features, when viewed through the lens of Carlson's flood hypothesis, provide a captivating narrative of ancient events. They tell a story of a world that experienced dramatic and sudden changes, a world that was shaped by forces beyond our current comprehension. But as with any groundbreaking theory, Carlson's ideas have sparked debate. His interpretations of the evidence and the magnitude of the flood he proposes have been questioned by skeptics. Despite this, Carlson stands by his theories, confident in the compelling narrative they offer. While Carlson's theories offer a compelling narrative of ancient events, they have not been without controversy. Yet, they continue to captivate those who seek to understand the mysteries of our planet's past. Whether you align with Carlson's ideas or fall into the camp of the skeptics, there's no denying that his theories have enriched our understanding of the younger Dryas and its global impact. Like any groundbreaking hypothesis, Carlson's flood theory has its skeptics. Indeed, it's a theory that has sparked spirited debates within the scientific community. Critics question the interpretations of evidence and the magnitude of the proposed flood. They argue that while there's evidence of a significant water event, it may not have been as catastrophic as Carlson suggests. Yet, the implications of this hypothesis are far-reaching. Let's consider the impact on megafauna, the giant creatures that roamed the Earth during the Pleistocene epoch. The sudden shift to glacial conditions during the younger Dryas would have created an inhospitable environment, potentially hastening their extinction. But if Carlson's flood theory holds true, a cataclysmic flood would have only added to their demise, wiping out food sources and habitats in a geological blink of an eye. The younger Dryas and the proposed flood would also have significantly affected early human populations. Faced with drastic environmental changes, humans would have had to adapt rapidly to survive. This could have spurred on technological advancements, the development of more complex social structures, and perhaps even migrations to new lands. So, while the debates around Carlson's theories continue, their potential implications for understanding our past cannot be ignored. They offer a captivating narrative of ancient events, providing a window into the dynamic relationship between Earth's inhabitants and their environment. One of the most compelling pieces of evidence supporting Carlson's flood theory lies in the discovery of megaflood scablands. Scablands, vast scarred landscapes carved by colossal flows of water, bear testament to Carlson's flood theory. These landscapes, left in the wake of the supposed Younger Dryas megaflood, are a physical testament to the massive scale of this ancient event. The discovery of these scablands is significant as they provide tangible evidence supporting Carlson's theory. These scablands, etched with the signs of a cataclysmic flood, allow us to delve deeper into our planet's past. They offer us a unique window to a time when immense glacial meltwaters reshaped the surface of the Earth, leaving behind indelible marks of their passage. Yet the implications of understanding such ancient cataclysms extend beyond the realms of history and geology. They are strikingly relevant in our modern world. By studying the Younger Dryas and other similar events, we can better comprehend the dynamic relationship between Earth and its inhabitants. Carlson's theories, for instance, have shed light on how sudden climate changes can dramatically impact life on Earth. They prompt us to reflect on the potential risks we may face if such cataclysms were to occur again. In this context, the work of Randall Carlson becomes not just an exploration of the past, but a guide for the future. His interdisciplinary approach, connecting geology, astronomy, and anthropology, provides a comprehensive perspective on the Earth's history and potential destiny. The Younger Dryas and Randall Carlson's theories not only captivate us but challenge our understanding of Earth's history.